Okay, so the next question I'm going to give you is from the same little group of problems on page 250. This time we're going to do number 13, and this will involve a different double angle substitution. So we start with the problem, tangent of 2x minus cotangent of x equals 0. And let's go back to the PowerPoint. So the tangent of 2x is the bottom one here, or the bottom left one here is how we're going to change it. So we'll change tangent of 2x to 2 tangent of x minus 1 over tangent squared of x. That will be our first step. Okay, so now in similar problems in just algebra, what we would do with this is we would multiply through by what we see in the denominator of our fraction. So I'm going to multiply each of the pieces, and that includes a 0 on the far right, by 1 minus tangent squared of x. So I'm left with 2 tangent x, because 1 minus tangent squared over 1 minus tangent squared cancels. And then I'm given 1 minus tangent squared x times cotangent. All right, so then I'm going to distribute my my right side of the left side, as it were. So we have just cotangent here, and then minus cotangent tangent squared. But cotangent's really 1 over a tangent, so this part here will reduce down to just tangent of x. So we have 2 tangent of x minus cotangent of x minus tangent of x. Excuse me, this should be a plus. I apologize. Let me fix that a little bit. It's a plus because when I distribute, I have a negative here and a negative here, which gives me a positive here. All right. All right, so let's continue. Okay, so then I combine like terms, so I have a 2 tangent of x and tangent of x, which gets me 3 tangent of x. And I can change the cotangent into 1 over tangent, because again, we're going to need a product, and I can't combine 3 tangent and negative cotangent just as it were. Okay, so now what I can do is let me scroll down a little bit. I can take and I can multiply the 3 tangent of x by tangent of x over tangent of x, so I can get a common denominator. So I have 3 tangent squared over tangent minus 1 over tangent. Again, because I can't just add fractions without a common denominator. Now my common denominator is tangent of x. So then when I add the numerators together, I get 3 tangent squared minus 1 all over tangent. Now, I've got a tangent in the denominator, which means I can put a cotangent in the numerator. Now I have the product I want. So cotangent multiplied by 3 tangent squared minus 1. All right, and I'm going to scroll down a bit again. And So now I'm good if either the first part cotangent of x equals 0 or if the 3 tangent squared x minus 1 equals 0. So let's deal with the cotangent first. So we have cotangent of x equaling 0. And again, we're going to do 0 to 2 pi. So this only occurs when x equals pi by 2 or 3 pi by 2. Because this is going to occur when our cosine is equal to 0. So cosine of x equals 0 at these 2 points in our unit circle. The one that's going to be a little bit more involved, let's do this one here, and I'll rewrite this as 3 tangent squared equaling 1 if I add 1 to each side of that equation there, which means tangent squared equals 1/3. And when I take the square root of each of these, I get tangent of x equals plus or minus, that would be root 3 over 3. And we look at our unit circle, so the first one where it's positive root 3 over 3 is going to be at pi by 6. And tangent is positive in quadrant 3, so that's also going to work if I just add pi to it, so 7 pi by 6. And then for the negative values, we go to the first one of 5 pi by 6. And if we add pi to that, we get to 11 pi by 6. And all 6 of these should be our solution. Again, a general solution, yeah, I can write that down. General, instead of just what my restriction would be, pi by 2 plus, n pi. Uh, and then we would have pi by 6 plus n pi. And then we would have 5 pi by 6 plus n pi if we were asked for a general solution. But the 6 that I have between 0 and 2 pi will work. All right, I'll do the next section, or not the next section, but the next group of problems on the next video.